Hi everybody, my name is Soil Maliki. I'm from Tehran, Iran, and the title of my final project is Applying K-means Clustering. Now, the overall look for my project is something like this. It is in VS Code provided by CS50, but I'm going to run this code in Jupyter Notebook and show you the project. Now just let me open up my Jupyter Notebook environment and bring up the code, and then we continue doing so. Okay, what I'm basically doing now, it's not something scary or I've you can open up Jupyter Notebook in Anaconda Navigator. You can just search here Navigator and open up Anaconda Navigator and open up your Jupyter Notebook. But I'm using a CMD command prompt, Windows command prompt, so that I can open up Jupyter Notebook. It's another way of opening up Jupyter Notebook. And this line, when I say activate data science, I have a whole environment which I'm not going to focus on. I've built a virtual environment and I've installed all the needed packages in this environment, which is named data science. This is not important. Now I'm going to run my Jupyter Notebook. Well, alright, now we see my Jupyter Notebook. Now I'm going to bring my code. Okay, now let's go to this part. Yes. Alright, so in the first part I've imported the essential packages. For my project we need pandas, and I've imported this as PD. I'm going to use PD dot etc, not pandas dot etc. And another package that we're going to use is numpy and matplotlib dot pyplot dot plt, or this line. And we need a sklearn, or the full name scikit-learn. We'll use scikit-learn.preprocessing for scaling our data, and scikit-learn.cluster for applying the k-means clustering. And I'm going to use sklearn dataset, that is load iris. It's the iris dataset, and I'm going to use this dataset for example in my project, because if you want to use machine learning algorithms, for example k-means clustering, you're gonna need a large dataset, and I'm going to use iris dataset for this. And if you are using this environment, Jupyter Notebook, to show the plots and charts and the diagrams that you draw, you need to use a line plt.show. If you don't want to use it over and over again, you need this line, matplotlib inline, that just does the trick. Now in my next part I've imported I've loaded my dataset into iris. So when I call iris, I call my dataset, and then I've used pandas package to make a data frame. I've used iris data, and my columns name are iris.feature names. This load iris has different parts. It's like dictionary, and iris.feature names has the feature names in it, so I'm using them for naming my columns, and the f.head shows an overall of my dataset. This is not the whole dataset, just a preview. So my dataset looks something like this. Now I'm going to use petal for this example. I'm not going to use sepal, so I'm going to drop them in this code. Axis equals 1 means we are going to use columns, so not rows. We are going to drop columns. These are column attributes. And I'm going to show my new dataset again. This is my dataset. Now there is a method in k-means clustering, which is elbow method. I'm going to apply it here. We have something called sum of the squared errors, or SSE. I'm going to use the same name, SSE equals an empty list. After that, I'm using for loop for number of k-means clustering need you to provide it with clusters, number of clusters, how many clusters you want. So that's the reason I'm doing this. And for example, I want to check from 1 to 20 the best number of clusters to use, and I'm going to make my model here in this line, and then I'm going to feed them to my data sets. And when I feed them, there is a method called km.inertia which returns the sum of the squared errors. I'm going to append it to my SSE. Now I'm going to plot it, plot my SSE versus range 1 to 21. This is something like this, and here you see this is something like an elbow. This is the number of clusters that I ought to use, and it is almost 3, so I'm going to use 3 for this example. Now I've plotted my data before clustering. My data looks something like this. Now I have scaled my data. There are different scaling methods. There are standard scaler, there are min-max scaler. I've used min-max scaler here. I've made the object named scaler, I've fitted to my data, and then I've transformed my data. And I've done it for the other attributes. If you remember here, we have 2 petal attributes. You have to transform them both. So now I show them to you. This is my new data. This was the previous data, and now it looks something like, where was it? Something like this. And I've drawn the same data over again. This is not different, so we haven't actually changed the data, we just scaled it. And now I'm going to make my object, my k-means clustering object with a number of clusters 3, and now I'm going to predict the clusters of my data here with y with y predicted, and I've shown it. These numbers here are the clustering numbers. For example, it means this data here belongs to cluster number 1, this data here belongs to cluster number 0, and etc. And I've added this to my dataset. I've added the cluster column to my dataset, and now I'm going to draw the final my dataset after clustering. I'm going to categorize my data. These are I'm actually filtering my dataset. These are the data that are in cluster number 0, these are data that are in cluster number 1, and these are data that are in cluster number 2, and we had 3 clusters if you remember. Now I'm going to draw them here, and this is the final results, my iris datasets. These are the centroids. We say k-means, these are the means, and we have 3 of them, and these red parts are the data that are in cluster number 1, green ones are in cluster number 3, and blue ones are in cluster number 2. So this is the result of my project. Thank you all for watching, and have a beautiful time. Thank you.